Here's the function that we're going to differentiate. X squared plus 1 over the square of x plus 3. First of all, we're going to use the product rule, and then we'll take the same function and we'll differentiate it using the quotient rule. To use the product rule, we first need to express this as a product. At the moment, it's a quotient. That is the result of dividing one thing by another. So let's write this as a product. We will have x squared plus 1, which is the numerator of the original function, multiplied by x plus 3 all to the power of negative 2. And now we have a product. So we can use the product rule. So we will say let u equal our first term here, which is x squared plus 1. And similarly, we'll have v equals x plus 3 all to the power of negative 2. And then in the product rule, dy by dx equals v du dx plus u dv dx. We need to work out the derivative of each of these with respect to x. So du by dx equals 2x. And here, dv by dx, we're going to need to use the chain rule to work this out. So we bring the power down, that's negative 2. We've got the same thing in the brackets again. We subtract 1 off the power, and then we multiply by the derivative of what's in the brackets. In this case, the derivative of x plus 3 with respect to x is 1. So it's not going to change our first bit here. Let's work out dy by dx. Well, here we have the form y equals uv. So I can say dy by dx is the derivative of this here. So we're going to do v du dx. So here's v and there's du dx. So we've got x plus 3 to the negative 2 multiplied by 2x plus u. I'm going to put the whole thing in brackets so there's no confusion as to what we're multiplying, multiplied by dv dx, which is negative 2 brackets x plus 3 to the power of negative 3. That multiplied by 1 hasn't affected this at all in any way. Right, let's put this together then. So now we have our dy by dx equals, I'm going to write these as fractions because I find it easier to work with. So 2x over the square of x plus 3 plus, here we've got a negative 2, so perhaps I could change that to a negative straight away. Negative 2, lots of x squared plus 1 over the cube of x plus 3. And now I can tidy this up by finding a common denominator and then adding the numerators. So dy by dx equals, I want to tidy this up as much as possible so that I can compare my answer to when I differentiate using the quotient rule. So if I multiply the numerator by x plus 3 and the denominator by x plus 3, the fraction has the same value. So on the denominator here, multiplying by x plus 3 will make this x plus 3 cubed minus 2 brackets x squared plus 1 on the numerator and x plus 3 cubed on the denominator. I can now subtract the two numerators and have a common denominator. So here I'm going to expand these brackets and take it away. So I've got 2x squared plus 6x over here from the multiplication of those terms. Take away 2x squared and take away 2 all over the cube of x plus 3. Now notice here we've got a 2x squared term minus a 2x squared term, so they cancel each other out and we're just left with 6x minus 2 as the numerator. And if we want to really tidy it up, I'm just going to squeeze it in here because I can. our final result for dy by dx will be 2 brackets 3x minus 1 as our numerator that's factorized all over the cube of x plus 3. So there's the result we're after. That's this original one differentiated. Now we use the quotient rule and we'll check if we get the same answer. Here's the quotient rule, got the same function. Let's see how this pans out then. The first thing we're going to do is assign what u and v is. So here I'm going to say let u equal the numerator, which is x squared plus 1, and I'm going to let v equal the denominator, which is the square of x plus 3. Straight away I notice I haven't got any negative powers, so perhaps straight away this method looks nicer to use. It might not be yet, still early days, but that's just my first observation. Du by dx is 2x, same as previously. But this one, dv by dx, using the chain rule, will bring the power down, that's 2. The brackets stay the same. Take 1 off the power, so that would be 1 there. And then you multiply by the derivative of what's in the brackets with respect to x. In this case, we multiply it by 1. We also need v squared. Now, dy by dx, because we've got this form u over v here, so dy by dx equals v du dx minus u dv dx all over v squared. There's v, x plus 3 all squared, multiplied by du dx, which is 2x, take away or subtract or minus u, which put in brackets there, x squared plus 1, multiplied by dv dx, which here is 2 lots of x plus 3. And that is all over the square of v squared. So using some wiggly brackets there, we've got x plus 3 squared. Well, let's tidy this up. Now to do that, I'm going to look for common factors in the numerator. I can say dy by dx equals, and let's have a look for some common factors here. So I've got this term and I have this term here, and so in common I've got 2 as a common factor of both of those, and x plus 3 is a common factor also. So if I take that factor out, that's 2 lots of x plus 3. If I take that out, and I'll use a different colour here to hopefully illustrate what's going on. So 2 brackets x plus 3 multiplied by x, and x plus 3 will get me all of this term here. X plus 3. Let's check that. 2 multiplied by x gets me the 2x, and x plus 3 multiplied by the x plus 3 gets me the x plus 3 all squared. Great. And take away, I've still got this term here, the x squared plus 1 term. But this bit here becomes just 1. The 2 brackets x plus 3 is there, so if we take that as a factor, it just becomes 1. That'd be a times 1 there, and that's the end of the green brackets. And of course, this is all over the square of the square of x plus 3. So that's x plus 3 to the power of 4. Now look here, I've got an x plus 3 as the numerator, a factor of the numerator, and x plus 3 is clearly a factor of the denominator as well. So I can cancel these. If I expand the brackets here and then multiply it by 2, I should be able to, or I could leave the 2 out as a factor. I should be able to tidy this up nicely, and it should give me the same result as using the product rule. Let's find out. Dy by dx equals, so I'm going to cancel this one here with one of those. Not sure I crossed the whole thing out there. It's still x plus 3 cubed. So on the numerator, I will have 2 brackets x squared plus 3x minus x squared minus 1. And my denominator will be the cube of x plus 3. Now this dy by dx, the derivative of the original function, will be 2 brackets, and if we just look at this, we've got an x squared here minus an x squared here, so they cancel, and we're just left with 3x minus 1 as the numerator, and the denominator is the cube of x plus 3. So we just bring in the other solution that we had. It's right here. We can compare the two, and they are exactly the same. So actually, whether you choose the product rule or the quotient rule is a personal preference. But sometimes the quotient rule is more appropriate, I would say, because it makes the factorizing easier and you don't have to deal with negatives.